Hello everybody. In this video, we'll be looking at the production scheduling problem. Um, Here's the problem. Chip Who's is the owner of Who's Custom Wheels, and Chip has received orders for 1000 standard wheels and 1250 deluxe wheels for next month, and for 800 standard wheels and 150 deluxe wheels the following month. So this is for the next month, is the month after that, and all orders must be filled. The cost of making standard wheels is $10 and the cost of making deluxe wheels is $16, and overtime rates are 50% higher, which means if you're making standard wheels in overtime, it costs $15. If you make deluxe wheels in overtime, it's going to cost you $24. Now, there are 1000 hours of regular time and 500 hours of overtime available each month. It takes half an hour to make a standard wheel and 0.6 or 6/10 of an hour to make a deluxe wheel. The cost of storing a wheel from 1 month to the next is $2. So how should Chip Who's manufacture the wheels so that all of his orders are satisfied, right? Okay. So let's begin with this problem. So we are going to again set up this problem as a linear programming problem. The first step is always the decision variables, and here we have to be careful. So usually in situations like this, especially with production scheduling sort of situations, you have to keep track of how many months are you producing for and what are the different kinds of products you're making. So at the very basic level, there are two products you're making. You're making regular wheels and you're making deluxe wheels. So that's two. Now these two products you're going to be making over 2 months. So you're making some deluxe wheels and regular wheels next month. You're making some deluxe wheels and regular wheels the month after. So you're going to be making it over 2 months, right? So that already adds an extra dimension. Moreover, you might not have enough time to finish making everything in regular time. You can make it in overtime. And the reason you have to track overtime is because overtime is more expensive. So you can either make regular wheels this month, or you can make it next month. On top of that, you can make them in regular time, in normal time, or you can make them in overtime. So what this does is it introduces a third dimension. So there are two possibilities, two types of wheels over 2 months, over two types of production processes, regular, normal time and overtime. So that gives you 8 different combinations, and so you need to have 8 different decision variables to manage those 8 different combinations. And this is how I'm going to manage the 8 different combinations, right? So I'm going to say SR1, right? It's the number of standard wheels produced in regular time, right? Produced in regular time for month 1. So I'm going to call them month 1 and month 2. So next month is month 1. The month after that is month 2. So SR1. So S is for standard, R is for regular, 1 because first month. So that way, those are the 3 dimensions that I have. But SR1 is a single quantity. So similarly, I'm going to have SO1, which is number of standard wheels. So, right, number of standard wheels produced in overtime, not regular time, but in overtime. For month 1, right? So that's SO1. So SR1 is for regular time, SO1 is for overtime, right? There you go. Now similarly, I'm going to have SR2 and SO2. So number of standard wheels produced in regular time in the second month, number of standard wheels produced in overtime in the second month, right? And we will double all of this, standard and regular wheels. But instead of standard wheels, we can have deluxe wheels. So it's deluxe wheels produced in regular time. So it's deluxe. So number of deluxe wheels produced in regular time in the first month, deluxe wheels produced in overtime in the first month, deluxe wheels produced in regular time in the second month, and deluxe wheels produced in overtime in the second month. So you have to track each of these individually because the cost of each of these is different, right? Okay. Now, apart from this, there are all going to be some technical decision variables or some inventory balance decision variables, right? So I'm going to have two decision variables. I'm going to call it SI, which is the inventory standard wheels. Now, it doesn't matter whether, so you can make extra standard wheels in the first month more than what is required and then carry them over as inventory to the second month. Why? Because it's cheaper to make in regular time. So maybe you can make more in regular time and then sell it in the second month. So SI is inventory of standard wheels carried over from month 1 to month 2. So this inventory of standard wheels. Similarly, I'm going to have DI, which is going to be inventory of regular deluxe wheels carried over from month 1 to month 2. Because you're only planning for 2 months, you just have to keep track of inventory carryover from month 1 to month 2, right? Okay, with all of this, we're done with decision variables. So step 1 is always decision variables. Right. Step 2 is the objective. The objective is to minimize the total cost. So we know that the cost of making a regular wheel is $10, deluxe wheel is $16, overtime rates are 50% higher, and carryover is $2, right? So it's $10 times the total number of regular wheels that you make standard wheels that you make in regular time. So that's SR1 plus SR2. These are all the standard wheels that you make in regular time over both months that cost you $10 plus $15 times SO1 plus SO2. So this is the standard wheels made in overtime in the 2 months, and then $16 times DR1 plus DR2, total number of deluxe wheels made in regular time in the 2 months, plus 24, right? 50% more than that of DO1 plus DO2. Right? So these are the total number of wheels made. This is the cost of manufacturing those wheels, plus $2 times the total inventory that is carried over, which is SI plus DI. Right? So total cost, and you want to minimize this total cost. Right? Minimize the total cost. And that's the objective. So cost of manufacture, cost of inventory, carry over. Right? Let's write the constraints. Now, what are the constraints? So remember that over the 2 months, you have to have, you have to have at least 1250 deluxe wheels in the first month. Sorry, 1000 standard wheels and 1250 deluxe wheels in the first month, and at least 800 standard wheels and 50 wheels and 1500 deluxe wheels in the following month. So let's look at demand constraints first. So there are 4 demand constraints. So the total number of regular wheels that you have to have available, standard wheels that you have to have available in the first month is 1000. So you have to have at least 1000 standard wheels 1000 standard wheels available in the first month. So standard wheels, those are SR1 plus SO1. So total number of standard wheels, whether they are made in regular time or overtime, those are the total number of standard wheels, and this has to be greater than or equal to 1000. Now, we're not going to say equal to 1000 because you could potentially make more and then carry them over as inventory, right? Maybe let's write that. So we're going to say that SR1 plus SO1, this is the total number of standard wheels that are manufactured in the first month. total number of standard wheels, whether they're made in regular time or in overtime, this has to be equal to 1000, which is the number of wheels that you need to, that's the demand for number of wheels in the first month, plus anything else. So anything over 1000 is carried over as inventory of standard wheels. So I'm just going to call them SI. So the total number of standard wheels, you're going to use them to either satisfy the inventory, which is 1000, or the remaining is going to become SI. That's why this is strictly equal to. So these are the total number of wheels at the beginning of the month. You either sell them or you carry them over to the next month, right? That's the first constraint. Now the next constraint is for the deluxe wheels. So you say DR1 plus DO1. So the total number of deluxe wheels. This has to be equal to the demand for deluxe wheels in the first month. And the remaining is carried over as inventory of deluxe wheels from the first month to the second month. So these are the demand constraints, demand plus inventory constraints for the first month. Now let's look at the second month. The second month, the total number of standard wheels you have are SR2 plus SO2 plus SI. So anything you carried over from the first month. The total number of standard wheels that you have available. And this has to be enough to satisfy the constraints, which is 800 standard wheels in the first month, in the second month, I'm sorry. So this has to be enough to satisfy the demand, which is greater than or equal to. So it has to be greater than or equal to 800. You could potentially make more, but you will definitely, very likely not make more, because obviously there's a cost minimization problem and it doesn't make sense for you to make more than 800, but I'm going to leave that option open, right? Similarly for deluxe wheels, it's going to be DR2 plus DO2 plus, okay, I'm sorry, my recording got cut off for a second. So the total number of deluxe wheels in the second month should be enough to satisfy the demand for deluxe wheels in the second month, and that is total number of deluxe wheels in the second month is 1500. So you need 1500 deluxe in month. So the demand, it has to be enough to satisfy 1500. So these are the inventory and demand constraints. So apart from this, you also have time constraints. You only have, you have 1000 hours of regular time and 500 hours of overtime available each month, right? So we're going to write four separate constraints for this, two separate constraints. So total amount of regular time that you need in the first month, that is SR1 is the total number of standard wheels that you make, and it takes half an hour to make a standard wheel. So half an hour times standard wheel. So this is the total number of hours required to make all the standard wheels in regular time in the first month, plus it takes you 6/10 of an hour to make a deluxe wheels times the number of deluxe wheels that are made in regular time in the first month. So this is the total amount of regular time that you need to make standard and deluxe wheels, and this cannot exceed the amount of time that is available, which is 1000 hours, right? So 1000 hours of regular time and 500 hours of overtime available. So that's the total amount of time required to make all the standard and deluxe wheels in regular time. Similarly, the total number of hours required to make standard and deluxe wheels in overtime. Cannot exceed 500 hours. Okay, what I'm going to do is smaller right there. That's better. Let's write the constraints here. Constraints like that. That's overtime for the first month. Similarly for the second month, 0.5 times SR2 plus 0.6 times DR2 has to be less than or equal to 1000 hours plus 0.5 times SO SO2 plus 0.6 times DO2 has to be less than or equal to 500 hours. Right? So 4 constraints here and 4 constraints here. There are 2 equal to constraints, 2 greater than or equal to constraints, and 4 less than or equal to constraints. Then you have the objective and all the decision variables. Right? So with this, we'll put this into the solver and solve it. I'm going to record that as a different video because it's already 15 minutes long. I'm going to put that in a different video. So this is just the formulation. We'll have another video for solution.